স্যার আফটার 21st করুন স্যার, বিকজ ওর আগে সিটি আমাদের
No, I'm not talking about that. I'm just asking whether we decided anything or not, a particular date. I know that the numerical analysis date is on 21st, right?
Yes, sir.
21st class time, that means this particular slot that will be used for the test. And for the CAD test, we can use the class slot again. That means sorry, next week, Wednesday, second half. Would that be acceptable? That means 22nd. You can discuss among yourselves. You do not have to tell me right now. Let me know tomorrow. Okay.
স্যার আপনার ডেডলাইন কি আছে স্যার?
I have to do it as soon as possible. So if you can give it this week, then that would be very helpful. But if not, then you can give it next week. But don't push it too far back. Means don't go beyond 24th, 25th. Okay, because I have to check all the assignments. I have checked a few already. But I have to complete the evaluation process by the end of this month. So don't push it back too far. Before 24th, 25th would be okay. Clear?
Okay, sir.
So discuss and let me know tomorrow. And just a reminder that the numerical analysis test is next week. That means 21st from say 11 o'clock. I will send you a link where using that link you will join a Google Meet session. In this Google Meet session, I would provide the link for the Google form with the questions. Syllabus for this test is the entire syllabus, and there would be some programming as well. Those of you who do not have computers, they can obviously do the programming using online IDs. There are online compilers available. I think you may have already done that. Some of you have been sending assignments in Word or some form of, I think some of you sent a snapshot also. I'm not sure, maybe not in this class. Anyway, so that would be the modality, around 1.5 to 2 hours for that test. Anyway, so what should we do today? Today's class is devoted for the program development. You may have seen from the title of the class that whatever we have discussed in the last class, we'll try to implement programmatically. I would not say all of the methods we'll try to do. Euler method is a very trivial one that I would leave for you to do. And the Runge-Kutta second order method is the one that we will concentrate on. We have already developed an algorithm for this in the last class. So for that, we'll try to develop a program and see how the solution varies with respect to one of the variables. After that is done, this is not going to take too much of time, probably 40-45 minutes. I want you to develop a code for RK method, RK4 method, that is the fourth order method, and submit it by the end of the class. Okay, it's not going to be too much of difficulty, I think. In fact, you can do it for both Euler method. Euler method is going to be a very short program, very simple program, probably 10 lines.
আমি একটু স্যার বাইরে আছি স্যার, একটু টাইম দেওয়া যাবে স্যার?
কতক্ষণ
স্যার?
হ্যাঁ, মানে তুমি কতক্ষণ টাইম চাইছো
স্যার? মানে
সাবমিট
আজকে বিকাল 5টার মধ্যে।
Okay, fine. I will keep as is the practice, I will keep the submission link open. You can submit it later also. But I would. Okay, fine, no problem, no problem. I will keep the link open. Whenever you get a time, you do the programs and submit it. Okay, but try to do it today.
Thank you, sir.
The others you can just try. No, I'm talking about the other students. The other students can try to submit within the class timing of 2 o'clock. Okay. If not, don't worry. The submission link will be open. But at least I want you to try to do these programs. This is going to also help you for what is coming up in the next week. That is your test. So shall we begin? Okay, let's start. Tell me if you can see the shared screen. Is it visible?
Yes, sir, it is visible.
Okay.
Yes, sir.
Okay. Welcome to this last class on numerical analysis of this course. And in today's class, we will look at how to develop a simple program for one of the solution techniques of an ordinary differential equation. In the last class, we have discussed about this topic, that is solution of ODEs or ordinary differential equations, in quite a lot of detail. There we have talked about a general ODE of the form dy dx equal to f of xy, where this f of xy is basically a general nonlinear function. So that is dy dx equal to f of xy. And it is provided alongside an initial condition which states that y is equal to y0 at the position x is equal to x0, which can be also written in the form yx0 is equal to y0. So this is the initial condition, and this sort of a problem is known as an initial value problem. That is, the starting point of the solution is provided to us, and on the basis of that, we are trying to develop a curve, let's say g of xy, or it might be presented in the form y equal to g of x, in such a way that at each point of this curve, the slope is provided by the given ODE. So we have the solution in two different forms. This one is known as, what is the known formula for this, name for this particular form? Can anybody tell me? And what is this? No one? Have you not read the
Sir, একটা মানে homogeneous or
No, not homogeneous. Which one is explicit and which one is implicit?
স্যার ফার্স্টেরটা হচ্ছে ইমপ্লিসিট ফাংশন হওয়া উচিত, যতদূর মনে পড়ছে।
This is implicit.
0
And this is explicit.
হ্যাঁ স্যার, তাই তো মনে হচ্ছে স্যার, ঠিকঠাক মনে নেই আর।
Okay, please read the note that was provided in class. Otherwise, it defeats the purpose, isn't it? If you do not read them, then what is the point of providing that? Anyway, so the solution can be provided in one of two forms, either explicit form or implicit form. And whatever be the formulation, we have different techniques or methods of solving these ordinary differential equations. One such method is the Euler method. There is something called modified Euler method. There is also a class of methods known as the Runge-Kutta method. In these methods, we use the information on the slope at multiple points. That means more than one point is used to get a weighted average of the slope, and that weighted average of the slope is then used in a general formula which is given here to calculate the next point in the solution. What is done generally is that, first of all, slope at a general point or intermediate point xj and several other points in and around that particular point is found out. Second step is to calculate the weighted average of these calculated slopes. And the final step is to multiply that average slope by the step size and then add it to the previous point to get the next point. So yj plus 1 is obtained as yj plus h multiplied by a summation of n1 to v bn kn, where bn is the weight and kn is the slope at the point n. So let me just write it out. That is the weight, and kn is the slope. What is n? N represents how many points are being used. If there are 2 points, then n varies from 1 to 2, and it is known as Runge-Kutta method of order 2. If there are 4 points that are being used, then n varies from 1 to 4, and it gives us a method of order 4. In that case, obviously, 4 different terms need to be summed up. For Runge-Kutta method order 2, you have n varying from 1 to 2, so you have summation over 2 terms. So b1 k1 plus b2 k2. Here is the graphical representation of the RK2 method that has already been discussed in the last class. I'll just quickly go over what this representation means. We have one known point over here, that is the initial condition. You can see that x0, y0 is provided, and this x0, y0, that is the initial condition, and it is known. With that value known and the slope at that point also known, we have to find out the next approximate solution. That means we have to find out y1. We consider a step size of h, that is the step size that takes us to the next point in the solution, which is x1.
Sir, h টা কি user defined হবে?
H could be user defined. H, it can also be defined in different ways. One is explicitly provide the value of the H. That means what is the step size you want. The other way of providing it is how many number of steps are required. That can also be provided. Suppose the solution interval is from x0 to xf. Let's say x0 is 1 and xf is 2. So in between this interval 1 to 2, I need the solution. That means I need to develop the curve. So one way of saying it could be that I would take a step size of h equal to say 0.05. That is possible. So that means you start at 1, next one would be 1.05, then 1.1, 1.15, like that you will go up to 2. The other way of defining h would be to give the explicit number of terms in or number of intervals into which that domain 1 to 2 is going to be divided. Let's say I want 20 divisions. So that is basically a roundabout way of saying that h is going to be 0.05. That way also you can decide it. So it is up to the programmer who is developing the program, and you can say it's a bit of a personal choice of which way you want to go. Until and unless specifically instructed in the problem statement that you have to take one way or the other as the user input, that means whether h is to be taken directly or number of subintervals are to be taken directly, you can choose either one of the methods and there is no difference between the two. Okay, so as I was saying that with the help of the initial condition and the slope provided at the first point, that's the known point, we have to go to the next solution, which is this. And how do we do that? First of all, we will calculate this point. So the slope is known. So that is S0 is the slope at the first point, this point. How do we know the slope? We know x0 and y0. So we can put it into this function. This function is basically the one that is given over here. It could be any function, general nonlinear function. If you provide x0 and y0 in this function, then you know dy dx at that point, at the initial point, which basically says that you know the slope at that point. So with that slope, if you extend the line like this, you intersect x1, this line, this vertical line at this point. Let's say that point is y1 bar. So what is y1 bar? In terms of expression, y1 bar is nothing but y0 plus the slope s0 multiplied by the step h. So basically this is y1 bar minus y0 divided by x1 minus x0 is equal to s0. S0 is the slope. We know from our basic understanding of coordinate geometry that this is the formula of the slope. And h can very easily be written as x1 minus x0. So that gives us the slope. And that is how we can calculate y1 bar. You can see here that s0 is known, y0 is known, x0 is known, x1 is also known. So basically the only unknown here is y1 bar, and we can calculate that. And once we have calculated that, we can put it again in this function and get a second slope at the second point. So this is the second slope. The procedure is the same. You just input x1 and y1 bar into the general nonlinear function that is provided to you as part of the ODE, and you will get this second slope. Once you get the second slope, then you can calculate the average slope like this. That is pretty straightforward. After you obtain that, you go back to the initial point, and with the average slope, you extend a line like this. Wherever that cuts the vertical line through x1 gives you the approximate solution. x1, y1. So what is y1? y1 is equal to y0 plus h into the average slope. Use the same general formula, you will get this form. So here y1 is the only unknown, everything else on the right hand side is known, so you get y1. So that gives you the approximate solution in the next step. Like that, you can continue on to this side and you can get solution for x2 at this location, x3 like that, and you can develop a set of values of y corresponding to x that gives you the solution of the ordinary differential equation. So this method was discussed in quite a lot of detail in the last class. So if you still have certain questions or queries or confusion regarding this, you can go back to the recorded lecture and listen to that. Now this procedure can be developed into a simple algorithm. This has also been done in the last class. This is the algorithm for Rangekatta method, order 2. And you can see that, first of all, we have taken the requisite inputs, then started a while loop. Inside the while loop, step by step, we have converted that graphical procedure that was explained just now into a program or into a sequential set of steps that gives you the value of this yi plus 1. Yi plus 1 here represents the approximate solution. Now, how can we convert this to the C code? That is the main focus of today's class. And without further delay, I think we can start converting it into a program. So for that, I'll need to move to the div C++ interface. And here, let me open up this template file, which I have already created. So here you can see the basic skeleton of the program has been written. That is the precursor part. The skeleton of the main program has also been developed. So this is the demonstration of ODE solution. And program is for RK2 method. Provide the date as well. Now we save it. Make a new folder over here. Let's give this name. RK2 will use while loop. And let's start. So first thing first, we need to provide the list of variables that we are going to be using. Now, how many variables would be required here? We get an idea from our algorithm. You see here that obviously xi, yi, those are the initial conditions. There is h, xf, and also there are 3 slopes. And finally, there would be xi plus 1 and yi plus 1. So let's use double and first write xi.
So, shall we use float? Will it make any difference?
Usually doesn't make any difference, but double has greater precision, greater number of places after the decimal point. So that's why I have used or have gone for
Okay, sir.
double. You
Sir,
can
you
use float as well.
Sir, you have put dot instead of comma, sir.
Is it? Okay. Thank you. Otherwise, that could have caused a problem later on. So xi plus 1 would be required. Yi plus 1 will need to be there as well. And now the step, let's write it like this. What else is required? The slopes. S0 is 1. S0, S1, and S average. These are the variables. Anything else? I think we need the final value also of the solution interval, that is the upper bound. So XUP. Under int, let's initialize I and a counter variable which is initialized to 0. So that is the initialization and declaration part taken care of. Now we can start the input process. That means how we take the input. So we need to write printf. There is some sort of prompt should be provided to the user so that he knows what he is trying to input. So we can simply write input initial conditions. I missed out on the quotation marks that needs to be provided. Then you write scanf and take the input. Format specifier for double is, what is it?
Percent LF.
LF, sir.
Percentage LF. Percentage LF, comma, percentage LF. 2 inputs to be taken under this initial condition, and they are to be stored in xi and yi. That is the initial condition taken care of. Next, we can go for the step size and the upper bound. So enter the step size h and upper bound of the solution interval. The upper bound of the solution interval, let's say xf. Now let us copy this and use the same thing over here. This is the step size H, S, P, P, and the upper bound is X, U, P. If we go back to the algorithm part, you can see that that is the input part, and that is already taken care of. We have taken the initial conditions Xi, Yi, we have taken the step size H, and also the upper bound of the solution region, which is Xf. So after this, we can start the while loop. You have to provide the condition. The condition is, as long as Xi is less than equal to the upper bound, then we go inside the while loop. That is Xi less than equal to Xup. Now inside this while loop, what do we have to do? First of all, we need to calculate the first slope, that is S0. Now from here onwards, it's a pretty easy task. So you have to just go on converting these statements into something which is understandable in C language. So you have to just convert these different expressions into the C language. So we just follow exactly what is written there. So we start with printf. What we are going to print? We have to print Xi and Yi. That we can see from the algorithm over here. So Xi and Yi need to be printed. So let me write percentage LF, put a tab, and then percentage LF again. And this is going to be Xi, comma, Yi. You can also provide a notation over here that helps you understand what value it is. Means the step, at which step you are. So I'll write percentage D. And here we will utilize the counter variable. This count was initialized to 0. So at the initial condition, at the first step, when it enters the while loop, it will print the 0th values. So the initial condition would be printed. In the next step, the next solution would be printed. Like that, it will go on towards the final solution. Now we calculate the first slope, S0.
Sir, semicolon hobe sir.
Yes. So what is S0? It is basically the function supplied with the value of the initial conditions. Here, Xi, Yi. Now what is the function? Function we have not yet defined. It has to be defined. But of course, I can develop the program on the basis of the function name. I can define the function later on after this main program. But let us now just go forward with the function name, which is func, func. And it has to be supplied with the values Xi, comma, Yi. And that would calculate the slope at the initial point. Next, we go for Xi plus 1. What is the Xi plus 1? This is simply Xi plus the step size. So that's what we have done here. What is Yi plus 1 now? Remember what we had done in the algorithm? Or here, Yi bar, that is Y0 plus S0 into H. So at the first step, yi plus 1 would be yi plus S0, or rather write it like this, H multiplied by S0. Here this is HSPP. So now we have got Y1 bar. We can calculate the next slope now. So S1 would be equal to this function supplied with the value of xi plus 1, comma yi plus 1. That gives us both the slopes. Next, the average needs to be calculated. Simple enough. 0.5 S0 plus S1. Now the solution, yi plus 1. This is going to simply replace the previous value which was stored over here. You do not need a separate variable for this. Simply overwrite it. And this is going to be yi plus the step size multiplied by the average slope.
স্যার বলছি সি কম্পাইলার ওই ব্র্যাকেটের ওখানটা আপনি দেননি ওই মাল্টিপ্লিকেশন সেন্টার
Multiplication হবে, there will be a multiplication.
হ্যাঁ স্যার সেটাই বলছিলাম।
You have to provide a multiplication sign over here. So next, what do? We replace xi with the value xi plus 1. Replace yi with yi plus 1 and make it ready for the next iteration of the while loop. So with these two values, it will go here. It will check the xi value with the upper bound of the solution interval. If it is less than that, it will again perform the steps that are mentioned over here. But before that, you need to keep in mind that counter variable, the count was initialized to 0. So with each running of the while loop, each iteration of the while loop, the counter variable needs to be incremented by 1. So count would be equal to count plus 1. You can write it in this way. It's typical of the C language, that you can use a short form like this to write the statement count equal to count plus 1. And that's it. Means there is nothing else to be done. If we check the algorithm over here, you can see that we have stopped the program after this. So in terms of the main program, that is completely developed now. What is left is what ODE actually you are solving. That means you have not yet provided the function itself. Here we have called the function. This is a function call with the values xi and yi. But what is this exact function? That needs to be supplied. So that has to be written after this. So I think we know how functions are to be defined. It has to have a representation like double. The name we have already given, so you have to use that name. And what would be the arguments and their type? X and Y. To define this variable, This is a local variable, of course, and S would be equal to sorry, the form of the function. Now it could be anything like x square plus y square, or ax square plus bx plus c, anything like that could be present here, could be anything. For now, let us use the function that we have used in our problem, because we can then at least see whether our program is supplying us with the correct answer or not. So what was the function that we used for hand calculation in the last class? I think xy, is it? Or was it minus xy? I think minus was there. Anyway. So that is where the function evaluation is done, and you return the value of s to the main function. So this is going to be returned over here. So what happens? Function gets called with the values xi and yi. Those values would come in these local arguments. Those will be stored in x and y. The expression s is equal to minus xy is going to be evaluated, and this function would return the value of s to here in the main program. So S0 receives the value of s, and then it will continue again till the function is called over again. So that is how it works. So I think the program is complete except for one thing. We have to declare the function as well as a function prototype, which is done here before the main function. And only difference is that here you will provide a semicolon. That is the function prototype. Let me write it also here so that you remember. The declaration of the function. So I believe it's complete in all respects now, but let us first of all compile it and see whether there are any errors. As you can see, no errors and no warnings. Now we will run it.
স্যার ওই আলটিমেট অ্যান্সারের ভ্যালুটাকে প্রিন্ট করানো হয়েছিল?
The value has been printed, I think, here.
Okay, sir.
There is the print value. Okay. This is going to give you the entire solution field, depending on how many h would be there or how many subintervals would be there. That is going to give you all the values. Anyway, let's see what happens. The input initial condition would receive 0 as the x value, 1 as the y value. The step size, as far as I remember, was 0.05, and the upper bound was 0.5 or 25. I think 25. So these are the solutions. Only thing is that I have not used a new line character. That's why they are coming all together in a continuous manner. So we can change that and provide, a new line function over here. We can run the same thing again. So 0 and 1. Step size is 0.05 and the upper bound is 0.25. And this is the solution. So at 0th step, that is the initial values 0 and 1, and from next step onwards you get the values. This is for 0.05, get something like this, 0.1, 0.15, like that you have gone up to 0.25. So I'm not too sure whether it is the same results that we had obtained in the last class, but seems pretty close to it. So that is how you can develop a short program for the RK2 method. Now variations are possible, of course. One variation is that you can use a separate sort of an input strategy where you are going to take, instead of the step size, the number of subintervals and the upper bound of the solution. And on the basis of these two input values, you can then calculate what would be the step size. So let's see how we can do that. For that, I'll just simply comment these two lines. So I can put those two lines have been commented. I can still copy this, use it here to save some time. Instead of the step size, here I will write enter number of intervals or steps within the solution interval. That means we are asking for n. Right, scanf. Now this is going to be an integer value. So %d, comma, address n. Remember that this has not been declared. So you should go to the declaration and under int, you should declare this new variable n. That gives you the number of steps within the solution interval. But one more step is required here. That is the upper bound. Let's copy this. Now we'll declare only one of them and we can get rid of this. But here an extra step is required where you calculate this value, the step size. And what is it going to be? Quite simple. The upper bound minus the initial value, that gives you the lower bound, divided by the number of steps. And that would give you this HSTP value. And then from then onwards, you have the same set of instructions, statements. It's a very simple variation, this one. But there are other variations also possible, which deals with this part of the program. That means where the iterations are taking place. Instead of a while loop, you may use a for loop as well. Now, how can you use the for loop? Let me just
স্যার তখন তো ওই একটা মানে ম্যাক্সিমাম নাম্বার অফ কতগুলো মানে স্টেপ হবে সেটা তো দিয়ে দিতে হবে ইনপুট হিসাবে।
You have already given the number of steps, you have already provided n.
Yes, sir.
Right? So your for loop would vary from 1 to the number of steps. So 1 to n, and for each of those iterations, each of those steps, it will calculate one set of value for x and y. Okay, let's see how we can do that. For that, I'll comment this part. That is the while loop part only. And we write the for loop. I would start from 0. It will vary till n and incremented by 1. Now within that, anything needs to change? Is there any need for any kind of change over here? There is no need. If I copy this entire thing and paste it over here, I think this is going to work. Because you see that xi, yi are known to us as a form of input. We have already calculated HSTP, that is the step size, and that is enough to start the iteration in motion. So S0 is calculated, xi plus 1 is calculated, then following from that y plus 1 is calculated, like that. Only thing that we have gotten rid of from here is that this condition checking. That is redundant now, because for loop is in any case going to end after n number of steps. So we do not need a condition check for that. So let's see if it runs or not, whether it gives us the same result or not. We have already compiled it and run it. So 0, 1. Now number of steps within the interval, divide 5. The upper bound is 0.25. Run it again, you will receive the same results. So I have shown you two variations in terms of the loop, but the content of the loop basically remains exactly the same. But one problem is there, I think. I have not copied the count variable, isn't it? So if I run it, let's check with what solution it gave. Actually, I was not paying attention to that one. So this is 5. This is 0.25. Yeah, you can see that this count does not change because I had forgotten to add that line. So it has remained over 0. In fact, if you think about it, this count is not required anymore. You can get rid of it because this index of the for loop, I, that can very well do the job of this count variable. So if I replace this count with I, then I think the problem will be solved. In that case, you would not require this variable at all. So let's see what happens. This is 5. This time, let me change this to 5, 0.5. You can see that this part is okay, but what has happened over here? I had given 0.5. The step size has changed. Number of steps remains the same. So it adjusts the step size to go from 0 to 0.5. Previously, it was 0.25. So the step size was 0.05. So it's a basic calculation that it has done. That is the flexibility of your program. And here you need to think about which particular path you are going to follow in terms of this, deciding on what is the step size and what would be the number of steps. And according to that, you need to write your program. So any questions from this part? Do you have any questions?
No, sir.
It's understood, right, how to write this? It's a very simple program, so should not be any difficulty in this. One more thing that I want to allude to is that you can also write the same program using 1D arrays. In that case, you will not require these two variables. Instead, you are going to declare xi and yi as one-dimensional arrays with certain number of elements. Let's say 100. So everything is going to be now saved within that xi and yi. You do not need a separate extra variable to store the next step of the solution, approximate solution. In that array, x0, y0 is going to store the initial condition or the given initial value. On the basis of that, you will calculate x1, y1, that is the next element of the arrays will store the next approximate solution, and x2, y2 will store the next one, and like that it will go on. In fact, we can try to write that program as well. For that, I'll just simply copy the entire thing and create a new file where we will try to implement that. So let's change this to an array of 100 elements. This is also an array of 100 elements, and we'll get rid of these. Nothing else needs to change. However, in the input side, this is going to be x0. We will store the input values in the first elements of xi and yi. These remain the same. That also remains the same. And when you come here, then obviously this needs to become xi, this needs to become yi. S0, that needs to change. And as the value comes back from there, then this has to change as well. We do not have anything called xi plus 1 anymore because we have gotten rid of that particular variable. Here, we will write it as like this, and that will be xi. This is I plus 1, and that is yi. Here, this value will replace this one, and This is going to replace this one. After that, that is the same thing. But yi plus 1 is going to be replaced by this array. This is yi. These two are not required anymore. So is that understood? Is that clear?
Yes, sir.
In fact, what you can think of is that those two variables that were required, they are now absorbed into this array. And one advantage of doing this is that the entire thing is now saved. In the previous program that we did with the help of while loop, you can see that the x0, y0 value, that is overwritten by x1, y1 in the first step. And then x1, y1 would be overwritten by x2, y2. So those values are not retained. If you go for this array implementation, 1D array implementation, then all the values would be available to you at the end. And the advantage of that is that you can do a certain kind of post-processing after this for loop is over, and you can store them in a different format. Maybe you can write a file, a separate doc file or .txt file or a notepad file, and in that you will be able to save these values. Let's see whether this is correct or not. Save it first of all. Okay, here I forgot to change it. This is going to be x0. Now it is okay. Initial conditions are the same, 0 and 1. Number of steps, let me increase to 10. And this one, now I'm going to give as 0.25. So you can see now that there are 10 steps in this, and these are the solutions. So I hope this is clear to you. So would you be able to write the program for the Euler method and the RK4 method? Euler
Yes,
method will be
Yes, sir.
very simple.
Yes, sir.
Okay.
I'm already working on the RK4.
Okay. Okay. Fine. So I'll stop recording and I'll leave you to do that. I have already prepared the link for the submission.
So what will be the function?
Function, you can take any appropriate function. Don't use this one. This is
স্যার বলছি স্যার
হ্যাঁ বলো
স্যার বলছি আমাদের মোটামুটি এনএমের যা সিলেবাস ছিল সেখানে যে কটা টপিক ছিল প্রত্যেকটা টপিক থেকেই আপনি মোটামুটি সবটাই প্রায় করে দিয়েছেন, ওই ছোট ছোট দু একটা করে টপিক বাদ আছে। যেমন স্যার
দেখো টপিক বাদ আছে বলতে তোমার একটা হচ্ছে তোমার
ফরওয়ার্ড ডিফারেন্সিয়েশন, হ্যাঁ
ফরওয়ার্ড ডিফারেন্স আর ডিফারেন্সিয়েশন, এই দুটো টপিক তোমাদের করানো হয়নি। আর একটা জিনিস যেটা আই থিঙ্ক উই হ্যাভ covered is Gauss Jordan elimination use করে matrix inversion.
হ্যাঁ স্যার।
That is, I think, pretty trivial. Means you are getting a diagonal matrix. So if that diagonal matrix is converted to a identity matrix, that basically takes care of the problem. Anyway, সেটা ক্লাসে বলা হয়নি, that is true. So these three topics, I think, are left. Others are all I have, I think, touched upon in some form or the other. Okay. So তোমার প্রশ্নটা কি ছিল?
মানে আমি স্যার বলছিলাম ওই মানে ডিফারেন্সিয়েশনটায় ওখানটা স্যার স্পেসিফিক্যালি মানে কি কি করতে হতো মানে আমাদের সিলেবাসটায় স্যার?
ডিফারেন্সিয়েশনে তোমাদের এমনিতে বেশ, let me just open up the syllabus. Okay, by the way, this is the link. দুটো প্রোগ্রামের জন্য স্পেস দেওয়া আছে। I think you can see this, right? This is visible? Is it visible? Can you hear me?
ইয়েস স্যার। স্যার আপনি ওটা গুগল ক্লাসরুমে পোস্ট করেছেন তো?
না, এখনো পোস্ট করা হয়নি, সেটাই আমি বলছি তোমাকে যে I will post this.
হ্যাঁ স্যার, আপনি ওটা পোস্ট করে দিন, আমরা তাহলে দেখি।
So these are the two problems. Write a C program to implement the Euler method. Choose any appropriate ODE along with an initial condition. তুমি তোমাদের ম্যাথসের প্রবলেম করানো হচ্ছে এই সেমিস্টারে, probably ODE solution রয়েছে তার মধ্যে as part of it. So you can choose anything from there. Obviously, order 1 hote hobe. Other orders you cannot do at the moment, but you can definitely do higher order solutions as well. But you need to make some modifications which have not been covered. Okay. And the second program is for the RK method 4. Here you have to choose. Maybe you can choose the same ODE so that you can see whether the results are matching or what kind of difference you are getting in this. Okay. Why is it showing untitled? It should not be untitled. Anyway. So the submission deadline is for today. That means you have till 12 o'clock at night today to submit this.
Okay, sir.
I'm going to assign this, and probably now you will be able to see it in your is it visible? Check and let me know.
হ্যাঁ স্যার, এসে গেছে।
Okay. And in terms of the syllabus that you were talking about, this is the syllabus. We have covered these initial parts quite well. This matrix inversion using Gauss-Jordan elimination was not done, but Gaussian elimination, which was not mentioned here, that has been covered. Iterative method, Jacobi's method, along with Gauss-Seidel has been covered. Here, Newton's forward difference formula and backward difference formula, these two were left out. Lagrange's formula has been done. That one was covered. Computation of derivatives using Newton's forward and backward difference formula. That is, in fact, related to this method of interpolation. So, if we know the backward difference and forward difference, then you will be able to do both of these. So that is the only part that has not been touched in any form. These things are already done. Euler's method. Modified Euler's is basically Runge-Kutta second order. It's just a different form of it. So if you do Runge-Kutta second order method, you have covered modified Euler's method. And fourth order also has been covered. So that is the extent of syllabus. I would just advise you in terms of the forward difference and backward difference that read it from the book. If you have any difficulty, you can then come to me and I will discuss with you. Okay.
Okay, sir.
Okay, so I will end this class. For today's topic has already been discussed.